All right, guys, Mr. Antonucci here, and we're going to talk in this section about significance tests for a population. So we're going to learn how to do a complete significance test for a population proportion, and then we're also going to talk about two types of errors we can make in a significance test, as well as how to reduce their likelihood. So in the previous section, we introduced the three conditions that should be met before we construct a confidence interval for a population proportion P. We called them random, 10%, and large count conditions. Now, these same conditions are going to need to be verified before carrying out a significance test. And remember that the purpose of these conditions is to ensure that the observations in the sample can be viewed as independent and that the sampling distribution of p hat is approximately normal. Now, previously, when we talked about the large count conditions for proportions, we said it required that NP and N times 1 minus P were both at least 10. Now, when we construct a confidence interval for P, we use the sample proportion P hat in place of the unknown population proportion. And we did this so that we could check the large count condition. In this section, however, we're going to use the parameter value specified by the null hypothesis, and we're going to denote that with a P naught. So if you look here, right here, we're going to use P naught. So we'll use this when we check the large count conditions. And the reason we use P naught here instead of P hat is because we're assuming the null hypothesis is true when we're performing a hypothesis test. So here's the conditions for performing a significance test for a test about population proportion. You got to check that it's random so that the data has to come from a random sample from the population of interest. And that sample has to be less than 10% of the population. So that's the 10% condition. And then both n p naught and n times 1 minus p naught. So in other words, the number of uh, expected successes and failures are both going to be at least 10, assuming the null proportion is true. Okay, so let's jump into an example here. Now, according to the U.S. Census Bureau, the proportion of high school students who have a part-time job is 0.25. An administrator at a large high school, that's important. They said a large high school. So we know the population is going to be relatively big. It suspects that the proportion of students at the school who have a part-time job is less than the national figure and would like to carry out a test at the 0.05 significance level of the null proportion equaling 0.25 and the alternative is 0.25, less than 0.25. So we have a one-sided or one-tailed test where P equals the proportion of students at the school who have a part-time job. The administrator selects a random sample of 200 students from the school and finds that 43 of them have a part-time job. So we're going to check the conditions for performing the significance that they're met, okay, for performing a significance test. So random. Now remember, I've talked before about how it's not enough to just write the word random and put a check mark. You have to explain how we know. And this is a random sample of 200 students from the school. Okay, again, 10%. You can't just say 10% check mark. Okay. Now, even though we don't know the population size, we do know that it's a large high school. So what we say is it is reasonable to assume that 200 is less than 10% of all students at a large high school. And then the large counts. Again, it's not enough to just put a check mark. You have to show that n p naught, which would be 200 times 0.25, which equals 50, and that's greater than or equal to 10, and n times p naught minus 1, which is 200 times 1 minus 0.025, which is 0.75. That equals 150, and that's also greater than or equal to 10. So the conditions are met here. And again, make sure we use the null proportion, um, not p hat, when checking the large count condition. Notice I didn't calculate 43 over 200. That would be the sample proportion. I'm using the null proportion here in the context here to determine that. All right, guys, that's it for this video. Hope that was helpful. Take care.